Hello everyone, my presentation title is ONOS-based KREONET-S Deployment and VDN Application System. We have been operating an engineering Korea research environment of network that is KREONET for advanced research and high-end educational organizations in Korea. Now, KREONET has nationwide backbone network with 17 region centers in Korea, and it has extended its international network based on 4 international connections to the US, China, and Europe. On top of the KREONET infrastructure, we started a new SDN deployment project called KREONET-S last year. The main purpose of KREONET-S is to migrate traditional hardware-based fixed and cloud network infrastructure and service toward software and user-driven virtualized, dynamic, and flexible environment. Here is the general architecture of KREONET-S, which has 3 building blocks such as data plane network infrastructure, ONOS-based control infrastructure, and KREONET-S SDN application and services. The data plane network of KREONET-S consists of hardware and software network devices for multi-vendor and multi-layer network deployment. And KREONET-S control platform adapts ONOS to provide carrier-grade high availability, failover, and scalability, which are all related to very reliable SD-WAN network operation. And there are KREONET-S application and service, which are the most important building block because this layer directly interact with end user to give them user services and experience. This slide shows the KREONET-S deployment control environment based on ONOS. You can see that here there is a 5-node ONOS cluster running on the top of the data planning network devices at the bottom. Each network device connected to the multiple ONOS instance in the controller cluster. For example, the 4 network devices in the Daejeon make a control connection to 3 ONOS instances in different cities, where one of the instances is operating as a master, while the other 2 instances working as a standby. So in this way, we want KREONET-S to guarantee SDN network reliability, high availability, and scalability. We developed KREONET-S infrastructure in 2 geographically distributed locations last year, that is Daejeon and Seoul. And this year, we have completed the new deployment in 2 locations. One is in Busan and the other is in Chicago, based on international long-distance SDN network. This slide shows the deployment status in Busan, with several photos of core and edge network devices, management switches, controller, OVS, experimental servers in one lab. Specifically for the deployment in Chicago, we collaborated with Starlight. Almost up to 90% of research networks in the world are currently connected to Starlight. So we want to use this long-distance international SDN infrastructure to expand the local user-oriented virtual network to other domain networks, such as Starlight, SDN, Korea, Internet 2, ESNet, and so on, in South and North America, Europe, and Asia. This ONOS GUI shows the current state of KREONET-S deployment as of today. This is centering around the hardware-based data plane network with a 5-node ONOS cluster. As mentioned before, you can see KREONET-S deployment in Chicago and Busan. And in addition to the hardware data plane network of KREONET, this global topology includes OS-based software data plane network. This is for various network experiments and user-side simulation, as well as the KREONET-S production SPM environment. From now on, I would like to talk about the application service on KREONET-S, which is a virtual dedicated network application. VDN can be generated on physical network by allocating network resources such as the switching port and link for some host group. Each VDN should be strictly isolated under SD-WAN environment, I mean between remote location and end user. In this way, each user group can see and manipulate their only their own VDN. In addition to the network performance and security, we have three design principles for VDN. First, we wanted to give network control permission to end user, so each user group can manipulate their own virtual network. Second, user interface should be designed to provide simple and rapid VDN manipulation, such as creation, update, and deletion. And third, each user needs to be able to visualize and monitor their own virtual network topologies with the proper operation and performance attributes. For example, delay, packet loss, jitter, and traffic utilization. This slide shows the VDN functional architecture. We are focusing VDN development on higher reliability and performance, and intuitive user group access and manipulation. New features, including ID federation and traffic monitoring, will be integrated with VDN as a third-party application. So users can have more visualization and monitoring attributes for their service convenience. We can handle VDN application by using free, CLI, and REST API. The REST API will be provided as a part of this new deployment plan for flexible and programmable interfaces communicating with other applications and services. V part is still working in progress. It will be finished at the end of the month. So today we show VDN Operation Demo based on CLI and REST API. In order to minimize the VDN generation time, we do network abstraction with a pruning strategy, unification of multiple links, and improve spanning tree algorithm. This figure shows the use case of VDN required 10 GB bandwidth with 2 VDN hosts. We first remove host and their ring. At the time, we check access switch for VDN host. And then remove not available link. Available link should support required bandwidth while not being allocated by other VDN. And then remove switching having no available link. And then we perform unification of multiple links between switches. Finally, we construct a spanning tree, which is equal to the VDN. This slide shows the VDN isolation policy. Based on any-to-any connectivity as a default behavior, the global topology getting sliced when users are creating new VDN. And each of VDN is strictly isolated in terms of the end-host interconnections. This slide shows the network recovery function. If VDN application detects remove link event, recovery mode first find related VDN and update it based on corresponding information for service continuity. We provide 5 command line interface for VDN application, VDN create, update, remove, list, VDN detail. We first show demo video for VDN operation based on CLI, including some parts of web. This is a global topology of KREONET-S. We type the VDN list. We can see the all VDN summarized information. At the time, just one. We create VDN, and with VDN host, you can see the ping between the host in the same VDN is operated normally. And confirm generate VDN by VDN list command and V. If you want to show detailed information about specific VDN, type the VDN detail and VDN ID or name. It can be also shown by V. This is the VDN topology view, just a single view. If you want to update VDN, changing required bandwidth, adding or removing VDN host, type VDN update with the changing parameters. We can check the changes by V and using CLI command. If you want to remove VDN, type VDN remove command and VDN ID or name. This is a demo video for VDN operation based on REST API. JSON format for creating VDN include VDN ID, required bandwidth, and VDN hosting. VDN can be created by using REST IP, and the ping between the host in the same VDN is operated normally. If you want to update VDN, changing some VDN name, bandwidth, VDN hosts, it can be done by same manner. REST IP for deleting VDN is also provided. Who will use KREONET-S? We are part of user group with the Astronomy Research Center and observatories in 4 different cities, Daejeon, Seoul, Jeju, and Ulsan in Korea. The new user will create their own virtual network, and the virtual network will also be used by dynamically joining end users for exchanging and sharing their research data with a very good performance. So let me conclude my talk here. In summary, KREONET-S is making new SDN development, operations, and services happening in Korea. And we are working on several experiments and collaborations for integrating technology with the ON.Lab, 5G, and other ONOS partners. Thank you for your attention. Thank you.